Okay, so I know this sounds very similar, but sequences and series are different. Okay? A sequence is just a list of stuff, right? A series is a sum of things. Okay? So the difference is we had an is n, right? That was like our dumbest example of a sequence. So we did 1, 2, 3, yada yada. Cool. The series version of that is the sum of the an, right, or sum of n, from n is 1 to infinity. I really shouldn't even write this.
How can you add infinity?
So I'm going to say, okay, well that's 1 plus 2 plus 3 plus and so forth, right? Which pretty clearly doesn't tend to a number. You guys see that? Cool? Yes?
Mm-hmm.
Okay, so I'm going to say over here, note this does not converge. What I mean by converge is actually sum to a number. You guys cool with that? However, some finite truncation, meaning if you cut this thing somewhere, will converge to a number, right? Because it's just a sum. So that would be something like the sum from n is 1 to capital N of n. That would be 1 plus 2 plus, and kind of so on until I got up to capital N. It's all good with that? You want to figure out a formula for this?
Isn't there something where you could like subtract capital N minus 1 to see how many are ones in between?
Yeah, there is something like that. So there's something like that as you could notice that there are pairs here. So that's an n plus 1 pair, right? Capital N plus 1. The 2 and the next term below n, those are going to add to what?
2 plus n minus 1.
Yeah, that's going to be 2 plus n minus 1, which is going to be n plus 1, right? See that? They add to the same thing. And then how many pairs are there?
Half.
Yeah, there's half, right? So this thing actually sums to n over 2, right? That's how many pairs there are. And then they all add up to n plus 1. Cool, this trick? So with that trick, we can answer this question. 1 plus 2 plus 3 plus yada yada plus up to 100 is what? Easy, easy, fast.
100 over
100 over 2 times
100 plus
101. Cool, check it out. That was nice. That was very satisfying, easy. Cool. Good. Yes?
I'm still kind of lost on how you got that original formula.
And how I got this guy? So I just did pairs. So I took the first thing and the last thing,
Okay.
and those add up to whatever the last thing is plus 1.
Okay.
And then the previous thing in this list was an n minus 1.
Okay.
Right? And so I took n minus 1 and added that to 2, because I hadn't used up the 2 yet.
Okay.
So n minus 1 plus 2 is n plus 1. I noticed that those are the same sum, right? So if I pair this thing up all the way down,
Okay.
and it's going to stop, because there's only finitely many of them, right? They all sum to n plus 1. And there are n over 2 pairs.
What if it's odd?
Question. Nice. What if it's odd? Then that thing's even,
So that you wouldn't have to add the one? Or,
No, you have to add the 1 anyway. But it turns out to be the other option. So this thing is also equal to n plus 1 over 2 times n, right?
okay.
So you can look at this a little bit differently and see the same thing in there. Fiddle with it for a minute, I promise it'll make sense.
Okay.
Try it with n is 7 or something. You'll see it. You guys cool with that? Okay, so that's easy short series with sum of n. That's a trick worth knowing. Put that formula someplace, you'll want it. And the other one we need is the geometric series one. So let's see, geometric series starts with A1, right? Why am I saying geometric series and not geometric sequence?
Because we're not doing the sequences.
Yeah, because we're just going to add this things that are in this sequence, right? So I'm going to sum the A1 r to the n minus 1s from n is 1 to, I don't know, what the hell, we'll go to capital N. Cool? You guys all okay with this giant mess of symbols that I've been writing here? So this thing means sum, starting here, going there. This stuff. Okay, so I got A1 r to the first thing. Where does this thing start?
A1.
Starts at n is 1, right? So that'd be A1r to the 0, right? So I don't really need to write that one. And then I want to add A1r
1.
1. Okay, leave that. Then I want to add A1r squared, right? And so on down here until I get to A1 r to the n
No, just a capital N.
capital N
Minus 1.
minus 1. Perfect. Cool. You guys good with this? Okay. You want a trick for this? Or do you want to see a geometric reason first? Geometric?
Sure.
Okay, cool. So let's try this with n is infinity, A1 is 1, and r is a quarter. Because there's a nice convenient picture for this. You guys cool with this? So I'm considering, right, kind of thinking about the sum from n is 1 to infinity of a quarter to the n minus 1 power.
Shouldn't you be a little wary about setting something equal to infinity?
Yeah. I should be. Basically, my concern, right, with setting n equal to infinity is that this sum might not wind up being something reasonable. You guys see that? We'll cut that particular bridge in half when we get to it. Okay, so I'm looking at this sum, right? So, first things first, what's in there? Like, what are the things I'm adding up? What do you get when you plug n is 1 in? Right? When this starts at little n equals 1, I get a quarter to the 0 power is 1, right? Okay, I know what 1 is. I'm comfortable adding that to stuff. Right? Okay, what's the next one I get?
Quarter.
Quarter. Okay, I know where to go get a quarter. I'm good with that. What's the next one?
1 over 16.
Okay, good, good. A quarter of a quarter. I know where to get that. I just got to get a quarter and cut it into quarters and take one of them, right? Yeah, can do that. Okay, what else? Okay, it's a quarter of a quarter of a quarter. Okay, this is getting messy. I'm just gonna like let that keep going for a minute, right? Okay, but there's a cool picture for this. You guys want to see the picture? Okay, so I need one thing first. So here's one thing, right? This is just a box with one thing. And for illustrative purposes, and because I know how this argument goes, I'm going to write 4 of them down. Ignore the man behind the curtain on that one. Okay, so this is one thing, and I'm going to polka dot this one thing, and I'm going to slashy this one, and I'm going to squiggle this one. Just because, trust me. Okay? So let's just consider the squiggly one because squiggles are my favorite. Okay, so I've got my one squiggly thing. Now what do I need? I need a quarter, right? Okay, I know where to get a quarter. I'm going to go take one. Luckily I have this. I'm going to cut it into 4 pieces. Okay, I cut it into 4 pieces, so I'm allocating that one to the squiggles. Okay, then I need a 16th, right? So I gotta go get a quarter of a quarter. I don't know. I mean, here's a quarter, right? Let me cut that in 4 pieces. I'm gonna allocate one of those to the squiggles. Okay, see this? Okay, then I'm gonna go get a quarter of a quarter of a quarter. So I'm gonna take one of my quarter of a quarters, and I'm gonna cut it into quarters. And then we're going to allocate that one to the squiggles. And then we're going to do this, and we're going to allocate the bottom left one to the squiggles. And we're going to do this, and we're going to allocate the bottom left one to the squiggles. Right? What do you notice? It gets smaller every time. And if I allocate the bottom left ones to the squiggles, the middle ones to the slashies, and the polka dot, sorry, the upper right ones to the polka dots. How much is left? Yeah, as I send n to infinity, right? As I go here, nothing's left. You guys see that? So what did I get out of this thing, actually? I get a number. This number is 1 and how much? How about let's go with this?
1 over 4 divided by 2.
How many things did I have to start with?
4.
4, right? And how many patterns did I split them amongst?
3.
3.
How many patterns do we split them on?
Right, and I allocated those 4 boxes equally among the squiggles, the hashies, and the polka dots. You guys see that? We could really think about that as 3 people taking an equal portion of those 4 things. You guys see that? Okay, so I think I should be able to come up with a way to sum things like this. And it's going to involve a slightly dirty trick. It's not this geometric argument. Okay? But you can use this geometric argument to realize a bunch of things like this. They're all kind of fun.
Erase the. No, you're gonna have that. Erase it.
Yeah, I'm not going to erase that thing because I'm going to use this and test it against it. Okay, so I want to do this slightly dirty trick. So I'm going to take all of these guys. I'm going to multiply by r. Right, so I've got my sequence A1. This one's kind of boring. Oh, we'll do this one. Yeah, what the hell? We'll do this one first. Okay, so I'm going to multiply this whole thing through by r. So what am I going to get? Did I lose you guys?
We're just gonna get the same thing times under.
Yeah, you're gonna get the same thing times r, so distribute the r through, right? So you're gonna get a1r
A1R plus A1R.
plus a1r squared plus, and dot to dot, and then at the end here, we're gonna get plus a1 r to the, yeah, I'm gonna get this guy, right, from this previous term. You guys see that? I'm doing this. That's multiplication by r, that's multiplication by r, that's multiplication by r. So that's multiplication by r, and then this is also multiplication by r. You guys with me? So I'm going to get a1r to the n here. You guys cool? And really what I'm talking about over here is r times this sum from n is 1 to capital N of a1 r to the n minus 1. Cool? And then my trick is going to be I'm going to add those two rows together. You guys see that? So over here, I'm going to get that sum from n is 1 to capital N of a1 r to the n minus 1. And then there's going to be plus and the exact same thing. Oops, not infinity. Capital N, a1 r to the n minus 1. And that's going to equal, oh, I said I was going to add, but adding is stupid. Why is adding stupid?
Because it's a geometry.
No, just because nothing's going to cancel. What's the point? Don't add that crap, subtract it. Why is subtracting better?
Give it one.
Yeah, because now a bunch of this crap drops out. So what are you left with?
A1 R minus 1, no minus 1.
Good, so there's the first term, right? And then those two cancel, and those two cancel, and this shit all cancels. And you get a a1 minus a1 r to the n. Cool? You guys with me? Right, now you had this whole thing, right? Minus r times that whole thing again. You guys with me? So factor that whole thing out. No. Okay, how about this? Call that thing S, right? For whatever the hell the sum is. So over here on this side, you have S minus RS. So that's S times what? A 1 minus R, right? You guys all see that? Okay, so now you can solve for S. What you know is that S times 1 minus R is A1 minus A1 R to the n power.
How did you get the 1 minus r?
I factored an S out. Right, if I distribute an S back in, I get S minus RS. So I got S times 1 minus R is A1 minus A1 R to the capital N. So S then is let me write this in the most convenient possible form, and you can just trust me that I factored for real. A1 times 1 minus R to the N over 1 minus R. You guys cool with that? Maybe kind of, sort of? Yeah?
Yeah, we didn't write it, yeah.
I'm pretty sure I've learned this before.
Yeah, I hope so. This should be the second time you guys have seen them. First time for everything? Yes, there's a first time for everything. Let's check our answer at least with the other one. So keep in mind this only works for geometric sequence, right? But it does work for geometric sequence. It should be noted that if you're going to go to infinity, right, that r to the n has to be small, right? Which means that your r has to be smaller than 1 to go to infinity. Cool? So with ours, we did capital N is infinity, A1 is 1, and R was a quarter, right? So let me just plug those values in. So my sum should be 1 times what?
1 minus 1/4.
1 minus a quarter to the infinity power. What's a quarter times itself infinitely many times?
Pretty much.
Very small.
Yeah, maybe actually 0. That's the area in that upper left corner of that last square, right? It vanishes. Okay, what's on the bottom there?
1 minus 1/4.
1 minus 1 over 4. So we got 1 times 1 over 3/4. Hey, look, that's 4/3. Cool, right? The nice thing is you can use this formula, right? When r is 1 over the square root of 2. Right? And finding the 1 over the square root of 2 in that square is probably hard. You guys cool with this? Okay, so I would like you all to take a second and do this for, see if you can sort out 2 different ways. One third plus 1 over 9 plus 1 over 27 plus and so forth.
Gee willikers.
Cool? So see if you can sort this out using both the summation formula and the picture. Cool? Ready, set, go. So I want to find out what the 1/3 plus 1/9 plus 1/27 and so on is, right? So I'm going to just assume that comes to a number. I'm going to call that number S for the sum. Cool? I don't have a good reason to think this right now. That's okay. So then I'm going to multiply S by -1 over 3. So I'm just mimicking the approach I used in the other one, but I'm going to do it without all those letters flying around. Maybe I'll catch a couple of you guys. So take this whole thing, and if you multiply it through by -1/3, one, it's going to put negatives on everything, right? And I'm just going to shift this whole deal over a little bit. Okay? What's 1/3 times -1/3? -1 over 9, right? And then a 9 times -1/3 is -1 over 27. And then the next term would be plus 1 over 81, right? But when I multiply 1 over 27 by -1/3, I get -1 over 81. And kind of so forth, right? Okay. Then if I add these two series together, right, on this side I'll get S minus 1/3 S. You guys with me? And on the other side I'll get just 1/3, right? You guys see that? This thing's now what's called a telescope. See, these two pieces collapse. These two pieces collapse. These two pieces collapse. Every piece that's in the top is going to have a corresponding piece at the bottom to collapse with. So all of these guys are going to add to 0. Kind of with me? So this gives me 0, which leaves me a third left over. So then I have how many s's over there?
2/3.
You have 2/3 of an s over there. Right? You have a whole s, and then someone took a third of it away. So you have 2/3 of an s is 1/3. So that one. Solve for s, right? So you flip and multiply, so you get s is 1/2. Right? That's me multiplying both sides by 3 halves and making a little onesie on the right hand side. Cool? So that's the exact same thing I did with the other one. I multiplied through everything by r, and then I added them together, and I ended up with a first term and a last term. This one doesn't have a last term on the bottom because it was of infinite length. So they all cancel. You guys see that? Okay. How else could you see this? So another thing you could do is you could use the formula, right? In that case, this S thing is A1 is a third, R is a third, and capital N is infinity. So you could plug that in the formula, you'd get a half out. How would you see this geometrically with a box or something?
Just opposite, take more every time.
How about make yourself a 1x1 box, right? And then split it into thirds. Okay, so I cut it into thirds, right? Now I need a 9. Right, so I'm going to take one of these thirds for myself, the squiggles. And then I'm going to take one of the other thirds and I'm going to cut it into thirds. I'm going to take one of those for the squiggles. I'm going to take one of those thirds and cut it into thirds. Oops. Yeah. Thirds. And I'm going to take one of those thirds for the squiggles. And a third and a third and a third, right? And pretty quick here, you'll figure out that if you don't do this too haphazardly, you will be left with half the stuff squiggled, half the stuff blank, and nothing left over. You guys all see that?
How did you come up with 2/3?
How did I come up with 2/3? I had one whole S, right? 3/3 of an S,
Okay.
and then we took a third away.
Oh, okay.
Cool? All right. Oh, I have homework assignments.